Hello everyone. So in this session, we will be learning about a new concept which is called as linear search. Well, this linear search can also be said as we have to find out if an array is containing a specific value, or we have to search if this array is containing a particular element which we are about to search. So for example, I have an element. I have taken a variable called as element, and this element value or variable has the value 89. We have to search if this array is containing the same element, or we can say if we have to find out if this element is present in this array or not. Well, to search a particular element or to find out a specific value in an array, there are few methods being provided. The first method is the linear search. In the linear search, what we are supposed to do, we are supposed to traverse the array by one step every single time and try to find out if that particular element is present in the array or not. How we are going to do that? Let's just find it out. So for now, we have taken an array of length 9 in which the elements are as 23, 45, 11, 67, 89, 55, 21, 90 and 1. The element which we are searching is 89. We have to find if this 89 is present in this array or not. For that, what we are going to do, we will traverse whole of the array one by one through each index, and we will try to find it out if this 89 is present in any of the indexes given in the array. So say for example, I have taken a loop over here I, and I have marked the value of I as 0. Now I will try to find out if a of 0 is equal to the given element. This is my condition which I will be finding out, or I will be applying on to. It means I will to find out if a of 0 is equal to 89. I will write here as 89, right? Is this condition true? Is a of 0 containing 89? No. The condition will remain as false, right? Next, I will increment the value, that is, initially I was over here and I have checked that the 89 element is not present at the 0th location of the array A. Similarly, now if it is not present at location 0, I will move on to the next location and try to find out if the element 89 is present at the next location. At the location 1 also, I will try to find out if a of 1 is equal to 89. Can we say what is a of 1? It is 45. Is 45 equal to 89? No. The result will be false. Next, I will move on to the next location and try to find out if it is present over here. Again, we have moved on to the second location, and I will write down if a of 2 is equal to 89. What is a of 2? It's 11. Is 11 equal to 89? No. The condition will be false again. Next, we will move on to the next location, that is 3. We have moved on to the next location and we are trying to find out if it is present at the same location. A of 3 is equal to 89. No, it's still 67. Therefore, not found for now. We will move on to the next location, that is 4. 4. If I will say a of 4 is equal to 89, I can say that a of 4 position has also the value of 89, and this has also the value of 89. It means the condition here is true, and voila, we have got the element which we were trying to find out. And if we have found out our element, definitely we do not need to move forward. If we even do to move forward and we will, for example, try to move on the value of I to find it out, it doesn't make any sense for us. unless and until one condition is there. But before that, it's very clear that we do not need to move forward to search if the element is again present in the list or not. Because according to our question, we just have to specify if the current element, if the specific value is present in our array or not. It has not been mentioned in the question, number 1 point, how many times the element has been present. If the question is like that, definitely we should search for the next element or the next location with the same element. As of now, the question has been mentioned that to find out if the specific value is present in your array, or the simple concept is linear search. So in both of these concepts, we just have to mention if this particular element is present in this list or not. If it is present, if you want to print the location definitely. We can print the value of I over here and we do not need to move forward. Clear? But still, if we want to move forward, we can. Let us move to the coding section to make it very clear. Here, I have taken the same array over here and I have taken the searching element as well. For now, I will be taking the loop over here as we have mentioned. So I will write down I is equal to 0, I is less than a dot length and I plus plus. The condition which we have mentioned is if a of I is equal to the given element. If it is true, what will we do? We can just print here true and we can exit. But, and I can also write if the element is not present, I will write over here false. But do you know how it will work? Let us just check it out. See, only at one location it has shown that it will be returning me the true value. In all of the false statements, it has also printed them. So definitely this is not the correct way, right? How we are going to do that now? Well, I will take a counter variable over here so that wherever the condition is true, I will definitely mark this counter value as 1. Or we can say just increase the counter value. Simple. So even at the 5th location, it has not matched that a of 5 is not equal to 89. It will return as false, right? A of 6, that a of 6 is equal to 89. Again it is false. At the 7th location, a of 7 is equal to 89. For now it is again false. And for the index value 8, 89, it is again false. So in whole of the situations, the counter value is only equal to 1 only at one single iteration when the value of a of 4 is equal to 89. It means the element has been found at this location. So can we use this technique? Yes, I will write down if the value of counter is 0 at here situation. See? If the value of counter will be 0 in all of the situations, we assume, suppose here also it is not 89, it's just 8. It simply means the value of counter will remain 0 at all of the locations. And if it is same, definitely we have not found the element. But if we have found the element, then definitely the counter of value will not be equal to 0. The value of counter will get increased. Same concept I will be using over here. What I will do, I will take a counter variable and I will mark it as 0. And I will say, if you have found the element, just increase the counter. That is it. Don't use else part here. What we will do, finish this loop and I will use a condition after this loop. I will say if counter variable is equal to 0, it means it has not matched with any of the element. It means not been found. And else element found at location. What? Have we saved the location? No. Well, if you want to find the location, please store it. Initially, I will mark it as 0, and here, when it is true, you can mark the location as I. I will store the value of I at location. Okay, and here I will print the value of location. And we are done. Can we run this? See, we have found that element has been found at location 4. We will assume if I have to search 8 over here, definitely it is not present in the list. Element found at location 0. Okay. One second, can we go it again? Okay. Can we try it again? One second. Let me just put these into this block. 45 is at 1, right? And 6 is at none position. Now it's correct. It was not actually executing these two statements simultaneously. Now if the element is equal to 6, or we can say even 8 as well, let's just find it out. Element has not been found. Okay, so this is how we can go for the linear search, or we can go for to find if we have to find a specific value present in our array. Hope you have got through this session very easily. Thank you so much for now.